We're moving on to video number 3. If you haven't watched my video number 1 or 2 for quadratic word problems, I recommend you watch those first and then you follow along here. So for video number 3, a farmer recently bought 500 meters of fencing to build new pens for their animals. They need 2 rectangular spaces of equal size. This farmer wants to give the most area possible for their animals to run around in. So what is the maximum area the farmer can enclose with 500 meters of fencing? All right, again, I like to always start with pictures. So what I'm going to draw here is a rectangle. And I'm going to break that rectangle into 2 equal pieces. When I think of rectangles, I think length and width. So I'm going to label the length, which means that this side is also the length. The width would be here, which means that this would also have the same dimension, and that would also have the same dimension. Here's what we know about the fencing, is that all of these sides have to add up to 500 meters, because that's what the farmer bought. So 2 L's, 2 lengths, plus 3 widths would have to be equal to 500 meters. What I'm trying to find in this question is the maximum area. Well, the area of a rectangle is equal to length times width. This is what I'm trying to maximize. In order to do so, I can't really do it unless I have only one variable on the right side. This is where my first equation is going to help me. Let's solve for L in this equation. If I can get L by itself, what I can do is substitute that into my next step. So let's get L by itself. What I'm going to do is subtract 3W from both sides. So I'll have 2L equals 500 minus 3W. To just get L, I want to divide both sides by 2. So the left side will become L, and the right side, I'll have 500 divided by 2, which is 250. And 3 divided by 2, I'm just going to leave it as a fraction of 3/2. And now I've solved just for L. What we can do is what's called substitution. This is what I'm really trying to solve. I want to have the maximum area, but I can't do that when I have 2 different variables. But what I've done here is I've written one variable in terms of the other. So what I can do is substitute it. I can replace L here with the equation I have, and then everything's going to be written in terms of W. So my area is going to be equal to 250 minus 3/2 W multiplied by W. Now we can solve this. We can either do this algebraically, but I'm going to do this into my calculator. So let's plug this into a calculator. I'm going to show you on the TI, and then we'll go from there. All right, so I already have the equation put into my calculator. So we would put that into y equals, and again, I've got 250 minus 3/2 x times x. What we're going to do now is graph this. So we need to adjust our window. When I go to adjust my window, the x values, remember, are my width. So the minimum width probably doesn't make sense to have it be a negative. So we'd want to maybe start that at 0. For the x maximum, when I go to think about, well, what would the maximum width be? If I have 500 meters of fencing, I probably wouldn't have it more than 250 because it would be 250 and 250. It seems even a little bit large at that. So maybe I would start at 150 as my x maximum. For the y values, the y value is actually talking about the area. So again, minimum area would be 0. We don't really talk about negative area. And then the maximum value, well, if I was going to assume that we had 150 and 150 for length and width, if it was a square, let's say, well, then what I would have to do is then multiply those together. I'd get an area of about 22,500. So let's maybe go 25,000, just overestimate a little bit. Let's see what this gives us. Oh, this ain't bad. I'm going to cut down here. This is a little bit of space, and I'm also not really seeing my other 0. So I'm going to go back and I'm going to make my x value. Let's go up to maybe, let's just do 200. And then let's bring down that 25,000. Let's maybe go to 18,000 and regraph. That looks a little bit better. What we're looking for is the maximum value. So on a TI calculator, how we do that is we're going to hit second trace and we're going to go for the maximum. You're going to take your cursor somewhere to the left, you're going to take your cursor somewhere to the right, and then you're going to hit enter, and it's going to tell us our maximum. So we have a max at 83.3. Seems like that's kind of continues, those 3s. And we have a maximum area of 10,416.667. So when I have a width of 83.3, I'm going to have a maximum area, which was my output, of 10,416 squared meters. So the max area is equal to 10,000, and I'm going to round this up to the nearest whole number, 417 squared meters. If you'd like to see more examples, keep watching these videos.